Hello everyone, my name is Parth Patel and I will be presenting the research paper Image Style Transfer using Convolutional Neural Network by Leon Gatys and his team. This paper is one of the most influential work in deep learning because it shows that CNN can do much more than classification, they can also create art. The motivation behind this work is very simple but powerful. Authors had a new idea of blending content of the normal photo and the style of artwork into a completely new image. Before this paper, CNN were mainly used for classification and object recognition, but this research opened the door to visual creativity, which later influenced GANs, diffusion model, and today's generative AI tools. So this paper represents a major turning point. It connects a computer vision with artistic creativity. The main challenge the authors tried to solve is that in any image, content and the style are mixed together. Content refers to the spatial layout, like the structure of the object in the image, and the style refers to the texture, color, and brush pattern. The difficulty is separating these two things and then recombining them again into the new image. Another challenge was to preserve an important structure from the content image while still applying the style. And finally, they needed an optimization method that could generate high quality result efficiently. Before this paper, most related work focused on a texture synthesis, basically like generating images with similar textures. CNN at that time were mostly used for recognition tasks, not for generation. But there was no method that could actually separate style and a content and then combine them. So this paper filled a major gap in this field. The key idea in this paper comes from understanding that a different layers of CNN learn a different types of information. Like early layers learn edges and small detail, middle layer learn shape and arrangements, and deep layer learn high level structure. The authors use a pre-10 VGG19 network and extract two different features. One is a content features and second is style features. Content features taken from the mid layer like a 4-2 because a mid level features preserve a layout and structure, and style feature captured using a gram matrix from a layer like 1-1, 2-1, 3-1, 4-1, and 5-1. This capture a multi-scale texture and a color pattern. Then they optimize a new image by minimizing a combined loss. A value of alpha and beta balancing how much the output resemble the content versus style. Here the authors show reconstruction from a different layers. If we reconstruct from a very shallow layers, we get a too much pixel level detail, almost like the original one. If we go deep, we lose an important structure. So a layer 4-2 provide the best balance. It keep the layout of objects but ignore unnecessary low level details. Style is not just edges. Style include texture, brushstroke, and color structure at a multiple scale. If we only use the earliest layer like a layer 1-1, we only capture tiny details. If we only use a deeper layers, we lose a texture pattern. So the author take the first layer from each block, like layer 1-1 through a layer 5-1, to capture a style from a small detail all the way up to a large scale stroke using a gram matrix, which is a correlation between features within layer. This multi-scale representation is what makes the result look so realistic and artistic. Here is the overall pipeline of stylized transfer algorithm. First, we pass the content image through VGG19 and extract a content feature from a layer 1-2. Then pass the style image and extract a style using gram matrix from a different layer. And then start with a random white noise image and using a gradient descent to update that image so that its content features match the content image and the style features match the style image. Over time, the noise slowly turn into beautiful style image. Others demonstrate that this method works on any pair of images. Starting from a white noise ensure the output is not a bias toward one of the input images. They also shows that a different value of alpha and beta change the balance. Like high value of alpha is like a generated image is more like a content image and a high value of beta is more like a style image. Overall, the result looks surprisingly artistic and capture both content and the style very well. Some of the major strengths of this paper are like this: it is a very simple but a powerful idea, and use a pre-trained network, no extra training needed. Also, it produces high quality artistic results. And this is the first paper to truly separate a content and style. Also, it become a foundation for a modern generative models like GANs and diffusion model. And it is one of those rare paper where a small concept has a huge impact. Of course, the method also has some weaknesses. It is slow because each output requires optimization. Also, it cannot handle a real-time video or large image efficiently. And style transfer sometimes fail for very complex style. And also, it depends heavily on VGG19 features. Later, some research paper improve these limitations. If I were to improve this paper, I would suggest training a feed-forward neural network to perform a fast style transfer. Also, like allowing a multiple style in a single model. I would say improving stability for a high resolution images using a more advanced architectures like a residual network. I would also suggest like adding a user controlled strength for more flexibility. Interestingly, many of these improvements appeared in later papers inspired by this work. To summarize, this research paper introduced a completely new idea like separating content and style using CNN feature maps. It also shows that CNN features are like powerful. They can represent a content of the image as well as the style of the image. And it also shows that CNN can be creative, not just predictive. This work directly inspired neural style transfer app, GAN-based generator, and a modern diffusion models. Overall, it is one of the most influential paper in visual deep learning, and it changed how we think about a digital creativity, and it also changed how we think about AI. Thank you.